Okay, this is, we're going to walk through this last 2 pages of the Trig quiz review packet. We're going to begin with problem number 4. So problem number 4 says, as an angle theta increases from pi to 3 pi over 2, state whether the following increase or decrease. So I'm going to sketch a unit circle. And then I have to figure out where pi and 3 pi over 2 are on my unit circle. So remember, 0 is at the positive x-axis. Pi over 2 is the same thing as 90. Pi is halfway around. And 3 pi over 2 would be where 270 degrees is. So we're going to be thinking about moving from an angle of pi to an angle of 3 pi over 2. And I'm putting an arrow to show the direction that we're moving, just so we can think about what's happening to x and y coordinates in that interval. So if we think about sine theta, that's going to be the y coordinate. So we have to think about what's happening to the y coordinate as the angle goes from pi to 3 pi over 2. And we can see that y is going down. So this is going down. And if y is going down, that means that sine theta is going to be decreasing in this interval. So we can just say sine is going to decrease. Another way to think about it, if you like, is sine is actually going from 0 to -1. It's decreasing. Let's look at cosine. So what's happening to the x-coordinate? So the x-coordinate, as we move from pi to 3 pi over 2, is moving to the left. To the right. So the x-coordinate is going to the right, which on a number line means that it is increasing. So the cosine is increasing, and cosine is going in this interval from -1 to 0. So it is increasing. Tangent. Tangent is a little bit trickier to think about. So if we think about, I'm going to draw a couple little triangles so that we can get an idea of what's happening. So let me draw a triangle. So if I'm in the third quadrant, I'll draw one that's an angle close to pi, and I will think about the x and y coordinates here. So let's call this x1, y1, and I'm going to draw a second triangle here, second right triangle, and I'll use a different color, and let's call this piece x2, y2. And remember, tangent is y over x. So at the beginning of the interval, let's look at point 1. So at point 1, the tangent is going to be, tangent will be y1 over x1. And at point 2, we're going to have y2 over x2. And we want to compare those two. Since both the x and y coordinates are negative in this quadrant, I'm just going to look at the absolute values of the x and y's because those negatives will cancel out. Okay, so I also know I need to add this to my analysis that tangent is positive in Q3. That's when the angle goes from pi to 3 pi over 2. So this is Q3. Okay, so I don't have to worry about it being positive or negative in terms of the x and y values. So as we look at these, we're going to see that as the angle increases from pi to 3 pi over 2, the y value is going to get larger. Okay, so the y value increases as theta goes from pi to 3 pi over 2, and the x value decreases as theta goes from pi to 3 pi over 2. And actually, I'm going to say the absolute value of x because I want to think about the sign. because we're doing the ratio and the negative signs are going to cancel out. So if we have a larger absolute value in the numerator and a smaller absolute value in the denominator, that means that this ratio will get top heavy and it's going to increase. Okay, so the ratio will get top heavy, and so the tangent is going to increase in this interval. All right, let's take a look at problem number 5. A spider is walking along the outside of a wheel of radius 3. And we want to know if the spider walks 6 feet, through how many radians has it rotated? So this problem is getting at the definition of a radian. So just to review that, a radian, so 1 radian is, remember this is a radius angle. So that's what we can think about. And that means it's an angle that intercepts an arc with length equal to the radius. Okay, so if you travel an angle of 1 radius, so this is what we did the first day, actually watched a video of that. So if I have an angle of 1 radian, so if this is 1 radian, that means this arc length is equal to the radius of the circle. That's what we have to understand to do this problem. So let's look at this problem. The spider walks 6 feet. Through how many radians has it rotated? Okay, so now I'm going to make a little circle for our spider. The radius is 3 feet, and the spider, Amy, is walking 6 feet around the circumference. So let's say this is 3 feet, this is 6 feet. How many radians did Amy walk, or the angle? How big is this angle is what we're asking. So each 1 radian would correspond with 3 feet on this circumference. So Amy walked 2 radians. Okay, so I'm going to write that down. 1 radian corresponds with 3 feet on the circumference. So 6 feet divided by 3 feet equals 2 radians. That's the answer to letter A. Letter B said, if the spider rotates through 1.5 radians, how far has it walked? Okay, so I'll make a little sketch that's saying that the angle that it's rotating through is 1.5 radians. So let's say this is 1.5 radians, and we want to find this piece of the circumference. So we have each radian corresponds with 3 feet. So we have 1.5 radians times 3 feet per radian. So this is going to be 4.5 feet as our answer. Problem number 6. Let's take a look at that. Find an angle coterminal to each of the following angles, keeping the units the same as those in the given problem. So the first problem is we have an angle of 5 pi over 7. To find a coterminal angle, you can add or subtract a full revolution, or actually a multiple of that. So for simplicity, let's just add or subtract 1 revolution. This just says find 1 angle. I'm actually going to find 2. So I can do 5 pi over 7 plus 2 pi. 2 pi is a full rotation. But now, because I have 5 pi over 7, I need to write 2 pi over 1 with a common denominator, which would be 7. So I'm going to multiply by a funny form of 1, which is 7 over 7. So that gives me 5 pi over 7 plus 14 pi over 7 is going to be 19 pi over 7. That is a positive coterminal angle. That's taking 5 pi over 7 and rotating 1 more time around. If I wanted to sketch what we just did here, 5 pi over 7 Remember, halfway around, that would be 7 pi over 7. So 5 pi over 7 would be backing off a bit. So let's say this is 5 pi over 7. And the angle that we just found is going on full rotation more. So it's going around and then ending back at the same place. So this would be 19 pi over 7. The other way we could find a coterminal angle is we could subtract a full revolution. So we'd have 5 pi over 7 minus 2 pi. So that'd be 5 pi over 7 minus 2 pi over 1 times 7 over 7. So it'd be 5 pi over 7 minus 14 pi over 7, which would be negative 9 pi over 7. Those are both coterminal angles. And if we wanted to sketch the negative 5 pi over 7, I'll draw that here. That would mean starting at the positive x-axis and rotating in the negative direction. So this would be negative 9 pi over 7. Part B asks us to find coterminal angles, but for an angle in degrees. So to do that, a full revolution is 360 degrees. So I can find a positive coterminal angle by adding 360 degrees. So that's going to be 430 degrees. Or likewise, I could subtract 360 degrees. That would be rotating in the opposite direction or the negative direction. So that'd be negative 290. The problem doesn't ask us to sketch it, but I will. So I'm going to sketch 70 degrees. So this is 70 degrees. And then the positive coterminal angle would mean rotate one time around first, a full revolution, and then end at 70 degrees. And the negative coterminal angle would be to rotate in the clockwise direction from the x-axis and then end at where 70 degrees is. So this would be negative 2, negative, let me make that look a little bit better, negative 290 degrees. Right, so a coterminal angle is an angle that starts at the positive x-axis and ends with the same terminal side as the original angle, but a different amount of rotation, and that difference is a full revolution. So that's 360 degrees if the angle's in degrees, or 2 pi radians if it's in radians. Okay, the next problem I'm going to do in two ways. So I want to find a coterminal angle to negative 3 pi over 4 in degrees. So the first way I want to solve it is just with a sketch. And see if we can reason through it. The second way, I could do the same thing that I did in problem 6 and then convert it at the end. So I'm going to sketch negative 3 pi over 4 in radians. So where is negative 3 pi over 4? Remember, pi over 4 is cutting 180 into fourths, or 45 degrees. And then we need to go in the negative direction. So negative 3 pi over 4 is this angle. And if we think about that, a coterminal angle could be found by simply rotating to the same location, but in the positive direction. So how far would that be? So now I'm going to start thinking in degrees. So halfway around is 180, and then the extra piece that I need would be 45 degrees. So this piece right here is 45 degrees. So I could think of this as 180 degrees plus 45 degrees, which would be 225 degrees. And that's just using reasoning from the unit circle. Let's just convert this. So if we want to do this like we did problem number 6, I could say 3 pi over 4. If I want a coterminal angle, I could add 2 pi, but I need a common denominator. So I'm going to multiply 2 pi over 1 times 4 over 4. So I'm going to have negative 3 pi over 4 plus 8 pi over 4, and that's going to be 5 pi over 4. And now I can simply convert this, and the conversion factor that I need, and that's going to be on the next page, is 180 degrees is equal to pi radians. And you'll need to know this in order to do a conversion. So thinking about like factor label like in chemistry, if 5 pi over 4, this is in radians. So I'm going to want to put radians in the denominator so I can cancel out that unit. So I'm going to have there are 180 degrees in pi radians. Actually, I should rewrite this. Let me write the radians in the numerator. So this is really radians is up here. Okay, so now the radians cancel out, the pi's cancel out. So that leaves us with 5 times 180 over 4. 180 divided by 4 is 45. So this is 5 times 45, which is 225 degrees, which is the same thing that we got just using logic from the unit circle. We could do the same thing. We could subtract 2 pi if we wanted to and find another negative coterminal angle. I'm not going to do that, but that would be another possible answer. Okay, let's flip to the next side. So then the next page, we've got a problem where we're going to just convert from degrees to radians. So if we want to convert 50 degrees into radians, we're going to say we have 50 degrees. And then we need to remember the conversion factor. Remember, 180 degrees is equal to pi radians. So if I'm going to convert this, I would say 180 degrees in pi radians. So 180 degrees in the denominator, pi radians in the numerator. The degrees cancel out. So this gives us 50 pi over 180 radians. We can divide both numerator and denominator by 10, which leaves us with 5 pi over 18. You do not need to write units if it's in radians. You can if you'd like. Number 9 is we're asked to solve an equation. So we're supposed to find all values of theta between 0 and 2 pi. So just in one revolution of the unit circle, where sine theta is rad 3 over 2. So we have to think about points on the unit circle where the y value is rad 3 over 2. So I'm going to think about the first quadrant. So which point has a y value of rad 3 over 2? Remember, rad 3 over 2 is larger than 1/2. So the y value is larger at the 60 degree angles or the pi over 3 angles. So those are, reference angles. So this point up here is 1/2 rad 3 over 2, and the angle here is pi over 3. That's one possibility. Where's another possibility? By symmetry on the unit circle, the other possibility would be in quadrant 2. Both of these will have the same reference angle, right? That's what's important in finding the coordinate. And I know I need to be in quadrant 2 because I want the same y value. I want the y value to be positive. So we're really trying to find when is sine equal to rad 3 over 2 on the unit circle. That's all we're thinking about. And we found those two places. It's when theta is equal to pi over 3 and 2 pi over 3. Okay, the last thing that we covered in class and that we'll review now is a little bit about trigonometric identities. These are equations that are true for all values of theta. And we did this by thinking about the unit circle. So here's one. We want to determine if the following are true for all values of theta. If it's false, provide a counterexample. If it's true, explain why it's true. So I'm going to sketch a unit circle. I'm going to pick some angle theta. For convenience, I'll put that angle in the first quadrant. So if I'm thinking about the point on the unit circle, let's say, we'll say that coordinate is a comma b. Remember, sine is going to be the y coordinate is equal to the sine value. And the x coordinate is a cosine value. If we add pi to that angle, that means we're adding 180 degrees. So we're actually going across the origin. So I'm going to get, this is my angle theta plus pi. When I do that, what happens to our coordinates? So by symmetry, the x coordinate is going to be negative a and the y coordinate is going to be negative b. So in this case, the y coordinates are opposites, which is exactly what this statement says. So this is going to be true. They have the same reference angle, which means that the absolute value will be the same, but the angles are in opposite, or are in opposite. I'll call opposite. No, I don't know if opposite makes sense. Are in, so quadrant 1 and quadrant 3, or it could also be or quadrant 2 and quadrant 4 if we had chosen an angle originally in one of those quadrants. So the sine values are opposite. So this is true, and we can deduce that based on our knowledge of the unit circle and its symmetry. Okay, what about cosine theta plus 2 pi is equal to cosine theta? So if we think about the unit circle, I pick some angle, let's say this is theta, and then I find the angle theta plus 2 pi. That means I go one full revolution again, theta plus 2 pi. So this statement is also true because we end up at the same, or actually better to say, because we have coterminal angles. Because theta and theta plus 2 pi are coterminal angles. So we have the same point on the unit circle, and cosine values are the same.